Low voltage controls. Woo! Okay guys, let's start with the contactors. This is the one that we're familiar with. We've been working on this one. This one's in all the air conditioners and our heat pumps here in the lab. Our single pole contactor. Single pole meaning we only have one side. That's one side of power that's controlled with a switch. The other side constantly runs through here and through the system, but we cut power to the compressor and that condenser fan motor by cutting just one line of power with one switch. Okay, flip this guy over. Now our coil is covered up, but a lot of the times you'll see it exposed and you can actually see the hunk of metal that's wrapped in conductors, and it's got like this little plastic looking stuff. It's just insulation wrapped over the top of it. But again, we're plugging our low voltage signal in here, our Y terminal, coming from our Y signal, our yellow wire, coming from our thermostat through our furnace into the outdoor unit. On this side or either side, doesn't matter. And on the other side, we're plugging in, if power goes in, we gotta have power getting back in order to energize this coil to create the magnet that we need. When we create that magnet, we close this plunger, bing bang boom. We pass high voltage to the motors. We have line power coming in here, L1, L2, or L1, L2, however you want to do it. And we have all our loads, our motors and stuff coming out the other side. And we break that circuit here with one switch on our single pole. Low voltage, power in, power out. Low voltage control, because we use a low voltage signal to control high voltage. Okay? Same thing going on here, only this is a double pole. These are both double poles. This one's new. It's actually got a cover over the contacts, which is nice because you don't get dirt and bugs and crud inside there to block those contacts up. Okay, it's the same thing though. This is an old one. It's all burnt out. But again, this is a double pole because we are controlling both sides of power with a switch. Here, we're only doing one side. Here, we're controlling both sides of power, L1 and L2, with a switch. Okay? Same concept though. This one we can actually see the coil. A hunk of metal in there wrapped in conductors. We put 24 volts to it, it energizes, creates a magnet, and we pull our plunger in and we pass high voltage from the supply side to the load side to our motors. Okay? We always want to check if this thing isn't coming on. If we don't get our switch to close, we always got to check our low voltage. Make sure we have low voltage there. This is an old school one. This is also a double pole. Turn this upside down, you can see it. This is an old guy. But here's our coil right here. Here's where we put our low voltage. Power in, power out. When we get 24 volts, we create a magnet. We're going to close this plunger. We have our supply, L1 and L2. We close this plunger and we pass power to our motors, which are going to be plugged in here. That's an old school one right there. You don't see too many of those. You're going to see mostly something like this or like that. Once in a while you'll see a single pole, smaller units, things like that. Heat pumps, most of the time out in the field, are going to have something looking like this. Contactor. Let's move over here to our fan relays. Okay, two different types. A lot of the times now in the newer stuff, the fan's actually controlled through a control board that's located in the furnace. If it's a gas furnace, it's being controlled with a control board. Even the newer electric ones, they're controlling it with an actual control board, but not always. A lot of times we have a fan relay. Okay, same concept. We have a coil in here. It's a hunk of metal wrapped in conductors, and this one's insulated. Okay, our low voltage go in the bottom rungs here. These bottom 4 terminals are for low voltage. This is going to come from our G terminal, or our green wire. Okay? We're controlling the blower motor inside the furnace. Power goes in, we got to have a common back. Doesn't matter what side you pick, okay? Same thing down here. These bottom terminals, 1 and 3, are our low voltage. Our green G terminal and our common back. Now the nice thing about these is they have 2 different circuits in here. These top 3 are one circuit. These bottom 3 are another circuit. And you can actually, if you wire it up right, there's a couple of different ways you can wire it in here. But if you'll see, there's some little symbols on here, and I'll get closer. So between the 1 and the 3 terminal, there's that little symbol there. That means that that is a normally open switch. There's a switch in there that's open. And if you see between the 1 and the 2, there's that symbol there, same symbol with a line through it. That means that's a normally closed switch. When something is in a normal position, that means that's a position that it will be in when there's no low voltage to this relay. So no power. Between 1 and 3, we have a open switch. When we put power to it, that switch between 1 and 3 will close. Opposite for 1 and 2. When there is no voltage to this relay, the switch between 1 and 2 is closed. When we put power to this relay, that switch will open. And the same thing down there between 4, 5, and 6. You can see those little symbols. This is the same concept. We just have a few less options. Between 2 and 4, when there is no low voltage to this relay, we will have an open switch. And between 5 and 6, we will have a closed switch when there is no power. When we put low voltage to this relay, the plunger will move, 2 and 4 will close, 5 and 6 will open. Let me show you that in a little bit more detail on the whiteboard. Here's my crude drawing on the whiteboard. This is representing this switch here. This is the most common one that you'll see. You'll see the other one too, but this one is the one you'll mostly see. Okay? Set this guy down. So if we hook power up to this side, this terminal, and we hook our other side up to terminal 3, we have an open switch in there with no power to the low voltage coil. When we energize this low voltage coil, this switch will close and pass power to this circuit. On the flip side, if we plug power into one side of our circuit into terminal 1 and the other side into terminal 2, we will pass power through this circuit, through this normally closed switch, when there is no low voltage to this switch or to this relay. When we put low voltage to this relay, meaning we get a signal on our G terminal, our green wire, this switch will open and we will cut power to this circuit. And it's identical down here. We can hook up multiple circuits to the 4, 5, and 6. This one over here, that's this guy. This one's pretty straightforward. If we hook a circuit between terminals 2 and 4, when there is no low voltage to 1 and 3, which is the low voltage coil on that relay, we will have an open switch. There's no connection between 2 and 4. We will have an open circuit. On the flip side, between 5 and 6, when we have no voltage to this coil, we will have a closed circuit. And we will pass power through there. Now when we put low voltage to this, again on our green, this is controlling our blower motor, so when we put power to our G terminal, our green wire, 24 volts, this plunger, this is a plunger that moves up and down, this plunger will move up. when we energize this. When we energize it, the plunger will move up, now making connection to 2 and 4, so that circuit will be closed and we'll move power. 5 and 6 will open and we'll cut power to 5, that circuit. All right, let's move on. Okay, sequencers. We talked about these already a little bit, but we're gonna go over them a little bit more, okay? You can't actually see the coil in these, but at the bottom part of this, in here, there's a small coil or a piece of metal that actually reacts to the heat that we're applying when we put 24 volts through here. We're moving amps, which means we have heat energy. The little strip of metal, it's rolled up into a ball, it will start to open up. And as it opens up, it will turn the switch, it will make contact with the switches and turn on. Turn on the switch in sequence, which is why we call this a sequencer. It's going to turn these switches on in a sequence, not all at once. And vice versa when we turn it off. They'll turn off in a sequence as well, okay? These are used for heat strips inside the electric furnace. Again, these bottom terminals here, are for our low voltage. We're powering this with our W terminal, or our white wire, coming from the furnace and thermostat. Okay? And then this actually has, if you look, M1 and M2 is one switch, M3 and M4 is another switch. So we can hook up 2 circuits to that, one on the top, one on the bottom. We can run 2 heating elements and a blower motor off of this. This one's a little bit bigger. Same concept though. We have 5 switches here. We have F1 and F2. Let me turn that around so we can see it straight. F1 and F2 is one circuit. M3, M4 is another circuit. As we go down, we have M5, M6, M7, M8. And then in there, that's going to be M9 and M10. See if we can get a little closer. M9 and M10. There's another circuit there. But they're stacked, which is why we call this a stack sequencer. It's a series of switches stacked on each other that open and close in a sequence, not all at once. We're going to get that signal from our white wire W terminal, and we're going to plug those in on the bottom. This is our low voltage control side here. Power in. Doesn't matter which terminal you plug it into on this side because they're all connected with this bar. But on the other side, if we put power to it, in order for that coil to energize, we have to have power coming out. So we have to hook our common up to this side. Again, either terminal, this one or this one, it doesn't matter. They're all connected. But as long as we have common on one side and our 24 volts on the other side, we will power the sequencer and the heating elements and blower motor will come on in a sequence. Stack sequencer. Moving on down the line here. Transformers. We talked about these a little bit this week in class, okay? You're going to find these. We have to, for low voltage controls, we have to get our low voltage from somewhere, and they come from these. We take the high voltage that's supplied to our equipment, run it through the transformer, and step it down to 24 volts so we can control all this stuff. And you can see on this one, if this is 120 volt, you'd hook 120 volts up to this, okay? So this would be our hot wire and our neutral wire. And then we'd have our R and C, or C and R, wouldn't matter, coming out the other side. Our low voltage would come out this side. And the coil, so this is the hunk of metal, and we're insulated here, but all our conductors are wrapped around this metal inside here, all our windings. This one's a little bit more complex. We got lots of wires coming off this one. This one, with all these wires here, this is our high voltage side. If you read here, our white wire is going to always be our common wire, whether it's our neutral wire or our L2 wire. And then based on what voltage you have, if you're hooking this up to 120 volts, you can step down to 24, you hook it to the black wire. So I would use the black and white wires for 120 volt. And on down the line, if I have 208, I'd use red. 240, I'd use the orange. I can even use this at 480 volts to step down to 24 volts if I had to with the blue wire. This one has all, and it's a lot heavier, obviously, than this one. There's a lot more windings in here that are hooked up to these different wires, so we can use it in all these different applications. This is a good universal transformer to have on your truck because you can use it pretty much anywhere. Okay, so a high voltage, then based on what voltage we have it hooked up to, we're going to have our 24 volts come out here. Our common and our red and our R right there. Move on down the line. Heat pumps. This is our reversing valve. We learned this from our refrigeration. For those of you who haven't had refrigeration yet, this is what controls the heat pump. We either move the hot gas to the outdoor unit or we move it to the inside unit or to the evaporator inside. And that will determine whether we're heating or cooling. We do that. It's a switch. We have it cut open here and there's a slide in there that will move back and forth. In the cooling mode, most of the time, this is a little coil here that's covered up, but there's a little hunk of metal with conductors wrapped around it. And when we put 24 volts to this from our orange wire, our O terminal, we're going to energize this coil, create a magnet, and based on the pressure differential that we have inside here, we're going to move it over and move the hot gas to the outdoor unit to condense and send the nice subcooled refrigerant inside so we can cool the house. In the heating mode, most of the time, when we cut the 24 volts to this coil, we lose the magnet, so de-energized, and based on pressure differential, it's going to slide the other way, and we're going to send the hot gas inside so we can heat the house with that, and we're going to evaporate outside, and we're going to be in heating mode. And that's all done with this low voltage coil that we run from the O terminal, the O wire, the orange wire. And last but not least, the thermostats. Okay, the different types, different kinds, touch screens. I mean, these are all Honeywells. Obviously, there's other brands out there. I don't know if you guys have ever seen the Nest thermostats. A little round one, looks real retro, but it's all digital. Those are getting really popular, really common. But I mean, these are just a few examples. But you can program these to come on, come off, different times of the day. But this is basically this is your control. This is basically just a series of switches, guys, that's taking that R wire from our 24 volt wire and switching the power around to go down, based on what we're telling the system to do. If we want it to cool, there's some switches that are going to close in there. Send 24 volts to the yellow wire and the green wire to have our compressor and our blower motor come on. In the heat, it's going to close. It's going to close the switch to bring on the white wire, which will energize our sequencer, and ultimately bring on our fan, our low-speed fan, and our heating elements on in a sequence. That's all these are, guys. It's a series of switches. We give it 24 volts. We tell it what to do. Based on what we're telling it to do, it will switch the power around to the different low voltage controls. Easy peasy. Let's go look at what one of these look behind this. Let's flip this over. We got all these little metal pins, but let's go look at what it looks like hanging on the wall. All right, here we go. We pull the thermostat off the wall, and this is what we have. Here's our thermostat wires connecting this thermostat to the furnace. Here's our red wire right here to the R terminal. And it's also jumped to RC. Okay, that's our 24 volts. When we tell this thing to go into cooling, here's our yellow wire on the Y terminal. It's going to send 24 volts down that white wire, or that yellow wire. And the green wire, which is the G terminal. We tell it to go into heating. It's going to send 24 volts down the white wire and do the heating thing. And we also have a common run to here, meaning we can power this thermostat without batteries. Some houses, some businesses, things like that, don't have a common thermostat wire ran to their thermostat, so we have to put batteries in it in order to keep the display on. Because remember, if we have power in, we have to have power back to the transformer in order to power something. So if we only have the R terminal ran to here, we can still control that 24 volts with the switches, but in order to control the thermostat itself, we have to have batteries in it. In this setup, we have a common run. So we have power coming in, we have power running back to the transformer, so we can power the thermostat without batteries. This one's not hooked up for heat pump, but if we were, we'd be looking at the bottom strip, heat pump here, and it would plug in. We'd plug the orange wire into the W terminal because that is our main heat source at that point. The white wire will come down here to this one, our aux or emergency heat, because that's secondary. But this one's set up for an air conditioner and furnace heat only. So we have the white wire, or conventional. We have the white wire plugged into the W. And we will go over all of that when we start wiring these things up and programming them in week 5. But our orange wire, it's tucked in right there. In heat pump mode, we would plug into this terminal here, this W terminal. Or heat pump mode, it would be the OB terminal right there. Okay guys, watch the video. Again, we're gonna go over all this stuff extensively in class next week. We're gonna hit all the low voltage controls. But check the video out, go over it a couple times. Yeah, bring me the questions you have and we'll go over the stuff in class. See you later.